It all began with the Atlantic Clipper, when Di and Ian met Jeff Allen, who designed, built, owned and operated this steel-hull hybrid wind assist small general-purpose sailing ship between the UK and Caribbean. At the time, climate change was emerging in the public discourse, and deploying wind assist on commercial ships seemed like a simple, easy-to-adopt solution. After all, world trade only came about because humankind has been using the wind to cross the oceans for thousands of years. Di met David Surplus, founder of the B9 Energy Group that began pioneering wind farms in the 1980s. From this meeting, B9 Shipping was set up. They were then invited to meet the Prime Minister at number 10 just before COP15 in Copenhagen, and the wind-assisted shipping concept was well received by Gordon Brown, the then Prime Minister. So Di set up a collaborative working group that included Humphrey's Yacht Design, shipbrokers, the Met Office, and academics from the University of Southampton. This group gathered in Dame Ellen MacArthur's sail loft to chart the way forwards. B9 Shipping's sister company, B9 Organic, was pioneering liquid biomethane production, biogas, fuel made entirely from municipal food waste. By combining an optimised hull design by Humphrey's Yacht Design and an automated dyno rig, we could generate 50% of the power need of the ship from wind. The necessary fuel would come from biogas. A 100% fossil fuel-free design, all by combining existing technologies in new ways. In 2012, we first started working with the University of Southampton to validate and verify our predictions using computational fluid dynamics and by working with a model hull. In the old University of Southampton towing tank, the scale model of the B9 ship was tested, overseen by long-term project partner Rob Humphreys of Humphrey's Yacht Design. We also tested a model B9 ship in the University of Southampton wind tunnel. Working with world-leading academics and overseen by the Maritime Coast Guard Agency, seen here observing through the window, we were able to validate the contribution the wind would make to the ship design. We had a powerful economic and commercial proposition, so we went to visit Drax. Drax, a pioneering UK renewable energy company importing carbon-neutral biomass into the UK. Drax needed to decarbonise their supply chain and were seeking ways to reduce greenhouse gas emissions in their shipping logistics. From this moment on, Drax have been a strong project supporter. They helped us figure out loading and discharge challenges. 2013-14 saw a failed bid for UK government funding alongside Rolls-Royce Marine and Lloyd's Register. Here we all are on Ålesund, Norway, working on the application. We visited associated British ports in Immingham to get on board ships working for Drax to figure out optimal sail installation points. Now, whilst we were unsuccessful at winning funding, Di won the One to Watch award at the 2014 Ship Efficiency Awards. And with ad agency McCann Erickson, we developed an ambitious new concept design to be showcased at Expo 2020. In that same year, B9 was sold to Gamesa, and so Di founded Smart Green Shipping to take the project forward. 2015 saw Di being invited to speak at various international green shipping events across the world. Di also featured in Lloyd's Register's advertising campaign at Nor Shipping in Norway and was invited to join the Clean Maritime Council to advise the UK Department for Transport on progressing wind assist to benefit UK manufacturing whilst making a significant contribution to global greenhouse gas reduction. The breakthrough came in 2018 when Smart Green Shipping won a small grant from Innovate UK. and was able to secure match funding from UKI2S and the Institute of Mechanical Engineers. Smart Green Shipping and Humphreys Yacht Design worked alongside Drax, who introduced shipowners Ultrabulk to the collaboration. We used one of their Panamax ships, the Ultra Tiger, a digital twin of that ship, and off the back of input from shipowners, crews, and port managers, Humphreys Yacht Design produced the concept design for a lightweight, retractable, intelligent, recyclable wing sail that we named FastRig, Future Automated Sail Technology, FastRig. Working with University of Southampton mathematical models, digital twins, we were able to verify that 6 FastRigs on the Ultra Tiger would save at least 20% fuel and greenhouse gases every year at her usual operating speed on her usual route. In 2020, Smart Green Shipping won funding from the European Space Agency to start developing fuel and greenhouse gas saving prediction tools. Using space-derived meteorological data processed by unique algorithms, we created a tool that combined University of Southampton performance data with Smart Green Shipping analysis to give the market confidence in the fuel-saving predictions we could make. And as a result of the Space Agency support, they helped us make some cool animations of the FastRig in operation, which was instrumental in Smart Green Shipping winning a large R&D grant from Scottish Enterprise. With the support of our Scottish partners Malin, we applied to build a demonstrator FastRig outside the COP26 conference centre. We were successful in winning the funding, but our plans were thwarted by the COVID pandemic. Eventually, in 2022, we were delighted to be able to announce our Scottish Enterprise support and that of other equity investors at a launch event at the Crichton Centre in Dumfries. At our event, our great friend and collaborator Graham Lester from International Futures Forum, who had suggested we work in Scotland in the first place, talked about Smart Green Shipping and the new business model that we were working with, pioneered by International Futures Forum. And at that same event, we were delighted to announce that we'd received approval in principle from Lloyd's Register for FastRig. And our next milestone was to build the land-based demonstrator and test it at Hunterston on the Firth of Clyde. So whilst the mechanical engineering and design for manufacturing teams were building a real-world test wing sail, the naval architects and scientists at the University of Southampton continued to refine the design and analysis tools. Evidencing that a wing sail design refined since the 2018-2019 work could save 30% fuel and greenhouse gas emissions per annum on the transatlantic route. As reuse is our ethos here at Smart Green Shipping, we built our test FastRig on a former wind turbine test site at Hunterston in North Ayrshire. And we sought the creative input from students at Lorne Street Primary School in Glasgow to inspire and create our new branding and design. In recognition for their work creating our brand design, we collaborated with Malin Group and hosted an educational and creative afternoon with Lorne Street Primary School students. Our theme was the power of wind and what you can do with it. With long-term project supporter IDEA, the design agency, we translated the Lorne Street Primary School student designs into graphics for the FastRig. Meanwhile, the wing sail construction was progressing very nicely, as shown here with some super images of the quality aluminium production coming out of Malin Group. Alongside this, Cali, now 360 Energy, were building the base where all the clever mechanical and hydraulic engineering is housed. In early 2024, we assembled the whole fast rig on site at Hunterston on the Firth of Clyde and began our testing programme. And now you're seeing the fast rig installed on the Pacific Grebe. With our fabulous collaborators from across the whole shipping ecosystem, we rapidly accelerate uptake of fast rigs across the 40,000 ships in the global fleet that Department for Trade predicts are suitable for wind. We've shown how we can develop robust and practical tested real-world systems to verify and validate our mathematical predictions. And now we're developing economic models that make access to fast rig wing sales easy and risk-free for the market.